Hello, we now come on to a section of the course where we discuss aspects of e-commerce and what I sometimes call lifestyle informatics and the use of recommender systems to advise people about what to do. Here, of course, we have our usual course in one sentence, and we're continuing to discuss the use of clouds, and the data analytics are the recommender systems for this problem. So this overviews the various problems you might be discussing. The first is matching people to products. Um, that's what you do in an online commerce site like Amazon. And also the same thing happens in offline sites such as supermarkets, where recommender systems are essentially used to optimize what products are placed on what shelves and things like that. In one case, you analyze people's web browsing habits and their rankings. The other case, you analyze how they traverse the store, or most easily just what they check out. In general, we're matching items to people or collections of items to collections of people. As a special case of an item, we have a person itself. So in social networking sites, effectively recommender systems are recommending people to people. Another good example is the job sites such as Monster or Career Builder, where we're recommending people to jobs or employers. And finally, another good example, which is maybe even more popular, is the information retrieval on search engines, where we use essentially a recommender system to decide which of the many possible matches to a query is the most appropriate match to present to people, or more precisely, which order we present items. So here's a little bit of discussion of recommender systems in more detail. This is a field that's a relatively old field in computer science, which has obviously exploded in value over the last few years. And now here's some just more examples. We start, of course, with the one we mentioned already, buying recommendations as at Amazon. You might suggest movies to look at, restaurants to eat at, events to go to, and books and music to buy. These are all seen quite easily on the web today. Another possible use of a recommender system is the Google News page, where some mix of user choice and automatic grouping of internet sites, Google produces an optimized customized page for every viewer. I already mentioned the real supermarket case, where you can decide on discounts and the placement of products. You can also decide what leaflets to send round to customers based on what they purchased and things like that. LinkedIn is a good example where your recommender system is used to identify possible colleagues. I'm always getting emails suggesting people I should relate to, or more precisely, when I go to LinkedIn, there's a stream of people they recommend to me. Here's a sort of rather philosophical remark that actually everything at least everything in this course maybe is an optimization problem, and many things in life are optimization problems. When we discussed the Higgs particle discovery, we had an optimization problem, which was fitting the model to the data. That model was a Higgs boson plus a background parameterization. And we've already this basic problem of matching users to jobs or books or to other users. That is an optimization problem. You're trying to minimize something or maximize something. And another general area is classification. That's optimizing the assignments of members of an ontology, which is a list of categories to data. Totally different example is if you're in a jungle. you try to keep alive, and then you try to optimize the distance between, which is in this case maximizing the distance between you and hungry lions. And of course, you do this sort of automatically. Your brain interprets the pixels detected by your eye to try to keep away from lions. So all of this can be thought of as minimizing a function or maximizing the negative of a function, because optimization is either minimization or maximization. They're trivially related by a minus sign. And we will see examples of this where we have different types of functions. So in fact, we have to choose functions in ingenious fashions to minimize or maximize, such as in the internet. Sites like Yahoo and Google and Netflix, their ultimate goal is to maximize money going to those companies. But at the same time, they want to maximize user happiness, because that happiness of the user is what will keep the user coming back, which actually comes back to optimizing money, because if the user comes back, they'll spend more money, either directly at Yahoo or more likely actually at the advertisers who advertise on Yahoo. So that's an example where Yahoo is trying to get advertising money, or Yahoo is just a generic internet site vendor, and we're trying to solve the optimization problem that the advertisers are maximally happy because a maximal amount of money gets spent at them. So this is relatively non-trivial. The function you're trying to optimize is quite distantly related to the actual web page, because it depends on who clicks and whether they actually make the decision to buy and so on. There are many examples where we can use analogies with physics, because physics often does minimization problems, and the systems you see in physics often can be thought of as minimizing what's called the free energy, which is a variant of actual energy, and the zero temperature is energy. In order to sort of formulate this optimization problem, it's often useful to think of the entities involved, the people or the books or the items you're trying to match with people, as points in a space. And that space, as we'll see, is not always a vector space. It can be a non-traditional space, with which may be because most important is not that there's a vector, but there is a metric defined in the space that allows you to define the distance between different points in the space. So if we look at the next part of the course, it has 3 sections, of which the first and the last are the most important one. It comes from an online site which has an good introduction to recommender systems and the many different approaches. Then we'll come to the Kaggle site, which is given an example of a place that hosts competitions, which competitions are often solving optimization problems. And in particular, that one famous competition was the so-called Netflix competition, where people were encouraged to find the best possible algorithm to optimize the movie recommendations that Netflix gave. And the final part of this unit includes some comments from Netflix on their approach, which comes from a SlideShare site.